So this lesson is going to be over the classification of matter. Before we learn how to classify matter, we need to know what the types of matter are. And there are two types of matter. The first type is a pure substance, and the second type is a mixture. So there are pure substances and mixtures. So a pure substance is can be either an element or a compound. It is something that cannot be separated by physical means, and that goes back to those physical changes we learned about in the first part of this lesson. Elements are something that is composed of identical atoms and cannot be decomposed by a chemical change. In other words, it's broken down into the simplest form that it can be. Anything on the periodic table is going to be an element, which is also a pure substance. So here are two examples. Copper and aluminum are examples. Things like oxygen, potassium, sodium, chlorine, fluorine, those are all examples of a pure substance in that they are elements. Compounds are composed of, oops, sorry about that, my slide messed up, I apologize. Compounds are composed of two or more elements in a fixed ratio that can be decomposed by chemical change. So their properties differ from the individual elements. So some examples of these are table salt, sugar. Anything that has a chemical formula is going to be considered a compound. Now, I could decompose those by chemical change if I wanted to, or I could burn the sugar and it would break that back down into the carbon and it would produce oxygen and water. Sodium chloride, I could put an electric current through that and break that back down into the sodium and the chlorine. Okay? There are two laws that govern pure substances, particularly in compounds, and they are, the first one is called the law of definite composition, and it states that a given compound always contains the same fixed ratio of elements. Okay? So in other words, when I have water, I always have 2 parts of hydrogen to 1 part of oxygen, and that makes water. Okay? So no matter where the water is found in the world, it's going to have 2 parts of hydrogen, 1 part oxygen. The second law is the law of multiple proportions, and that states that elements can combine in different ratios to form different compounds. One that you're familiar with would be carbon and oxygen. They can form either carbon dioxide, or sometimes they will also form carbon monoxide. Okay, so they're allowed to form different compounds, but when they do, they are still doing so in a fixed ratio, and they're still following the law of definite compositions. The picture we have here is an example of nitrogen and oxygen, and as you can see, it can actually form quite a few different compounds, and then it shows you their ratios at the bottom. Now, mixtures are something that can be separated by physical means. So they can be physically separated. And there are 2 types within mixtures. The first type is called a homogeneous or homogeneous mixture. Okay? That has a uniform composition, and we sometimes call that a solution. Okay, and by uniform composition, I mean it looks the same throughout. You can't tell a difference. So for example, if any of you wear contact lenses, you use saline or contact lens solution to put your contacts in, and if you look at it, it looks the same throughout. You can't see the different parts of that solution. A heterogeneous mixture is the opposite. It is not uniform in composition, and you can visibly distinguish its parts. So it does not have a uniform composition. Okay? There are 2 types of heterogeneous mixtures, and they are colloids and suspensions, which we will get into further in the year. Okay? We will get into those later. So let's give some examples of these so you can kind of know what we're talking about. In terms of mixtures, we have 3 types. We have the solutions, which are homogeneous, okay? And so that means that they look the same throughout. And here are some examples of mixtures that are solutions. They can be solid, liquids, or gas. Their particles are evenly dispersed, and they are very small, and they will not settle out. They have no Tyndall effect, which we'll talk about a little further, but basically if I pass a stream of light through the solution, the light will pass straight through and it won't be scattered, so we say it has no Tyndall effect. So here are some examples. Gatorade, of course, is one. Brass is another example. It's actually called a alloy, or a metal alloy, which is two metals that are a solution. That's how we get things like brass, bronze, stainless steel. Those would all be examples of a solution or a homogeneous mixture. So a colloid is a little bit different. A colloid is got particles that are intermediate in size. They won't settle out, but they do have the Tyndall effect. So if I was to pass a beam of light through a colloid, I would actually see the beam of light travel through it. The very best example I can think of that is fog. Think about driving on a clear night when you're driving with your headlights. You can't see the beams of headlight pass through the air. Now, you can see where the headlight hits the ground or the wall or whatever, but you don't actually see the beam of light. But on a foggy night, if you put your headlights on, you can see the beam of light traveling through the fog. And that's an example of the Tyndall effect. Okay? A suspension is basically exactly what it sounds like. It has very large particles that are so large that they will settle out unless the mixture is constantly being stirred, shaken, or agitated. So here are three examples. Italian salad dressing is one of the best examples because we know that if we shake it up, it looks like it's mixed, but then if we let it sit, the particles separate back out and the oil and the vinegar in the dressing separate again. Okay, same thing with muddy water. If I was to let it sit for a little bit, the mud would all fall to the bottom and then you'd have a clear layer on the top. We are going to skip this since we're doing this as a flipped lesson, so you can skip past this. Okay. This brings us to the matter flow chart. The matter flow chart is going to show us how we can help decide what these things are. So when I see something, I first ask myself this question: can it be physically separated? In other words, could I boil off the water? If I dissolved salt in water and I boil off the water, I get the salt back and I get the water back separately. So that would be an example of a physical separation. So we would say, yes, that it can be separated by physical means, so now it's a mixture. So we would go to the mixture side. Then we would look at that salt water and we would say, is the composition of it uniform? In other words, if I look at it, does it all look the same throughout? Okay, and the answer would be yes. And so if I do, I would go to a homogeneous mixture. Okay, let's say I'm looking at chicken noodle soup. Can I separate it physically? Well, yes, I can take the noodles out, I can take the chicken, carrots, whatever. So I would go to the mixture. But is it uniform in composition? No. When I look at it, I can visibly see and visibly distinguish the separate parts, so it's a heterogeneous mixture. And then, by the sheer fact that I know there's big pieces of noodles and chicken, I would know that it was a suspension. Okay? But let's talk about sugar. If I just had table sugar, can I separate it by physical means? And I can't, so I'm going to say no, so I'm going to go to a pure substance. And then I'm going to ask myself, can it be chemically decomposed? In other words, can I break it down into smaller units? And the fact that sugar is made with carbon, hydrogen, and oxygen, then yes, it can be decomposed chemically, so I would say it's a compound. So that is how that matter flow chart works. And that is where we're going to stop, and then you'll do the next flipped lesson on Canvas.